The IOStream library is fairly rich, but most of it is there as back-end support, so there's really just a few classes you'll normally use. Here I have a working copy of IOStream formatting.cpp from chapter 10 of the exercise files. IOStreams come in two basic flavors, input streams and output streams. We've seen output streams with this cout class from IOStream that overloads the left shift operator and displays stuff on the console. In this case, we're going to see a demonstration of cin, which uses the right shift operator to take something from the console that I type in and put it into, in this case, a string class variable. And in order to demonstrate this, I'm just going to comment out the rest of this file. We'll get back to this in a moment. Just going to comment out to before the return statement there. And I'm going to build and run. And you see that I get a prompt here from this cout. And then I'm going to take input into this string, and I'm going to display it on the console. You notice that when I type more than one word, it discards everything but the first word, and it just takes that first word. And that's really the way cin works, at least by default, and it's kind of why most people never use it. Instead, what I'm going to do is I'm going to use getLine, which actually is more line-oriented, but it doesn't use a string. So I'm going to comment out this string here, and I'm going to comment out this stuff, and instead, I'm going to declare a C-string buffer, which looks like this. And then we're going to use cin.getLine and give it the address of the buffer and the size of the buffer. And then we'll just cout the buffer and an end line. And I can also be nice and give it a little string here. And now when I build and run, oops, there we go. Now I'll type in 1, 2, 3, 4, 5. And you see we get the entire string. Now this seems a little awkward because it's actually using a C string, a plain character buffer, but that's the way that getLine works. And if you're going to use cin, this is the way most people will get input from the console. All right, so I'm going to go ahead and comment all of this out. And I'm going to uncomment the rest of this. And we'll take a look at some output formatting with cout. Now, cout by default, if I just build and run this, it's a lot of stuff, but I'm going to scroll up here to the top. Cout by default does things like this. You give it some variables. I've got 42, 127, 55, 55, and it just displays them just like that. And the default is in decimal, and it has its default formats. You can modify the format of things with manipulators, and these manipulators like hex, showbase, oct, decimal. These manipulators are special member functions that are used without arguments as part of a stream. And so in the case of hex here, see that these are the same values, but they're now in hexadecimal. If I use hex with showbase, then I get a 0x before the hexadecimal values, but they're the same values, you see that. I can use octal, and you notice that it still has showbase set, so it has a 0 in front of these octal numbers because I set showbase in a previous cout and it remembers that. And then I can get back to the default by saying no showbase and decimal, and then we get our results again. Now, here we are with floating point numbers. And so starting here with pi and 1234.5. And so these are the default formats. So the fixed manipulator gives us this result here. The scientific manipulator gives us this result here. And if I give a set precision with the scientific manipulator and fixed, then I get this result here. And set precision 7 with scientific, and I get this result here. So you can see there's a lot of flexibility available. And this IO base float field is used to reset the defaults. There's also string formatting options, and so I have these 3 strings: normal, large, and extra large, S1, 2, and 3. I can set a width and have them right flushed to that width, which you'll notice here. And I can set a fill so that the right flush has these dashes, or I can set it back to a space, which is the default. And then I can set it left to display left. So finally, I just want to give one more note. You notice that each of these ends with an end L. The end L is actually a manipulator also, and we've seen this throughout the course. End L is a manipulator that provides an end-of-line character and also flushes the output stream buffers. And so it's actually very common and is the right way to end a line rather than just putting a new line character in the string. IO streams can also be used with files. And so I'm going to go ahead and delete this working copy here and make a working copy of iostreamfile.cpp. And I'll run clean. And I'm going to build and run, and you can see the output here. It's really quite straightforward. You open an output file for write using OFStream, and you'll notice that I'm including here FStream header. And so you open a file for write with OFStream, and we're creating this object O file, and we give it the file name, which is a C string file name. And our text string here is also a C string, and so I have an integer line number that starts at 1 because it's initialized to 0, and I'm using pre-increment here. So line 1, 2, 3, and we have this result there. I'm writing it to this out file, and then I close the file with ofile.close, and then I open the file for reading using ifstream, and I create an ifstream object called infile with the same file name, and I use infile good to tell me that I can still read from the file. So as long as I can read from the file and I haven't got to the end of the file, that will remain true. And then I'm using getLine, which we saw earlier, to read into this static character buffer. And then I see out the result and close the in file. And then I delete the file with the standard library remove function. So this is really, really simple and straightforward. And all of the formatting works exactly the same with the OF stream as it does with cout. So the IO stream library is very useful for basic generalized IO, including interfacing with the console and writing to and reading from files. For more control, you may use the C standard library functions for reading and writing files.